So this assignment has 5 problems, and it's one of the easiest assignments, 4 problems actually. It's one of the easiest assignments that you'll see towards the end. Really simple assignment, not very difficult at all if you understand, again, if you understand what is to be done. Uh, Also, this topic is very interesting in its own right, probability. It's actually one of my favorite topics. So I'm glad that I'm doing this assignment intro. So I'm going to go through the problems and explain what is being asked and what you can do to solve the problem. As usual, there are multiple ways to solve it, and you're welcome to try your own way. But as I said before, all of these problems are not very long. So most of these problems can be solved in a few lines of code. Having said that, let's get started. So problem one, I'm also going to make notes on the left at the bottom in note 17. So I hope you can see that. So problem one is about simulating a dart game, and here you're going to make two kinds of dart guns, so to speak. Now we are simulating, so essentially you're going to simulate the throws of darts by using the random number generator. Now MATLAB has lots of different random number generators. The one that we'll need in any given problem will be actually hinted at by the problem itself. So for part A, you're asked to create a function that takes in an input n and outputs an n by 2 array of x and y coordinates. And the x and y coordinates should be normally distributed with a mean of 0 and standard deviation of 10. So there it is clear that you have to use a standard normal distribution, okay, of the random. So you have to use, let me actually put it a different way. I'll say the random number generators come in MATLAB come in different flavors. Okay, so in problem one, in part A, you're asked to generate choose x and y coordinates from a normal distribution. So here you're going to use the normal distribution and with a mean 0 and standard deviation of 10. Now the standard MATLAB random number generator with normal distribution generates a random number between 0 with a mean of 0 and standard deviation of 1. So you need to make that, like, modify it, transform it in a very simple way to get a random number distribution with mean 0 and standard deviation 10. And that is explained very well in how to in the help pages of MATLAB. So I'll just say here hint C help rand. So C help MATLAB help for those functions. Okay, it's very easy. Don't have to do a lot to get such a normal distribution. And once you get that, you just do the same for x and y coordinates, concatenate them, and output your array, the n by 2 array, as shorts. So it's just very few lines of code. In part B, you're asked to create another dart gun, this time with a uniform distribution. So here again, instead of the normal random distribution, you'll use another flavor of the random number generator, and that typically MATLAB generates random uniform numbers between 0 and 1. So here the problem is asking to generate in the interval minus 10 to 10. So again, the help page of MATLAB explains how to do that, and you can just see it. It's a very simple transformation to get a uniform distribution. All right, so that's simple enough. Again, very few lines of code. In part C, you're asked to write a function called dart score that basically takes in two inputs, n, which is the number of shots attempted, and f dart, which is a function handle to one of these two dart guns that you just created, and outputs the total, the tally, and the shots. So here all you have to do is essentially note that So the f dot, so first you create the shots. So let me actually make this in more detail here. Dot score dot m. So here you have to first create the shots using the f dot function handle with the input n. Okay, so f dot of n, and then you find the total, tally, and shots. So how would you do that? So according to the scoring scheme given in the problem, you if you refer to figure 1, you see that there are three concentric circles. So if your dart lands in the innermost concentric circle, then you get 10 points. If it lands on the border of the inner one, or between the border of the inner one and the outer circle, then you get 5 points. And if it lands between the border of the second one and the outer circle, then you get 10 points. And anyway, outside is 0. So all you do is simply take the shots and find where it is on the board. And one simple way to do that is just calculate its distance from the origin. And once you do that for each shot, then just find out how many of them are at a distance less than 1 from 0. For that, you will give them 10 points. Then find how many of them are distance between 1 and 5. Those will get 5 points, and so on and so forth for 1 point and 0 point. And then you just add up the points, total them, multiply them by the appropriate multipliers, and get the total and output the tally. So just find distance from origin uh, to figure out how many points that shot gets. So find distance from origin of each shot. Okay, so that's all you have to do in this one. Score it and then tally it out. So that's the simple part. In part D, you're just basically going to use this function with a large number n equal to 10,000, and then answer those questions based on the answers you get. So just n equal to 10,000, oops, small n equal to 10,000 with dot score. So that's all there is to say for problem 1. You get the outputs from the tally. You can see how many of them got at least 1 point, at least 5 points, and so on and so forth. All right, moving on, problem 2. So here again, you're playing a dart game, but instead of using the dart gun, you're gonna throw the darts according to the given x mean, x deviation, y mean, and y deviation. So note here again that you're going to use a normal distribution. So use the appropriate random number generator. And here you're given what the mean deviation of the x coordinates and the y coordinate should be. So you should transform the random number generator appropriately to get the x coordinates with that x coordinates normally distributed with that mean and that deviation, and similarly the y coordinates distributed with the given mean and given deviation. So once you generate these x and y coordinates, just as you very similar to how we did in problem 1, that is basically your that will give you the shots, and then you score it up, tally it up in the exact same way as you did for problem 1c, and find the probabilities by just dividing the total number of shots in each sector with the total number of dart throws. So again, a very simple problem. You're just combining concepts used in parts A, B, and C to write this function. It says here specifically to not use a for loop to generate the dart positions. So which means you don't go generate shots one by one at a time. You can do it. You have to do it vectorially. You have to generate an array of random numbers, uh, normally distributed, and use those directly to get the shots. So that's all there is to problem 2. So don't generate array of normally distributed random numbers. No for loop. So it's entirely based on problem 1 and should be easy enough to do. Problem 3 is where you're simulating another game, this time a game of dice, and you're going to write a function, roll dice, which takes in two inputs, number of dice and the number of rolls. So both of these are single scalar values like 3 and 10. So you're rolling, that means you're rolling 3 dice 10 times. And the output of that function should be the average dice, which is the average of the sum of the dice values from each experiment, and his dice. So first let's look at average dice and then I'll explain what his dice is. Average dice is simply the sum of the scores you obtain on each throw divided by the total score, divided by the number of rolls that you did. So if you did say 5 rolls, then it is basically divided by 5. Okay. Now that is your average dice, and his dice on the other hand is basically a huge 6 times num dice by 1 array. So what does that represent? It represents the probability of getting, say, if you look at his dice 5, they'll give an example. His dice 4, so I'll use that one. His dice 4 equal to 12. That means that the sum of the throws of the dice is equal to 4 12 times. Okay. So note the dimensions of this array. The dimensions of this array are given by 6 times num dice by 1. And why is that? Because the maximum value that you can get by throwing the dice is when each of the dice rolls, if you roll a 6 on each of the dice. So the maximum value that you can possibly get as the sum of the values you scored on each of the dice is 6 times the number of dice. So that's why the size of this array is 6 times num dice by 1 array. So what you need to do is first generate a set of throws. So here, note that it specifically asks you to use the rand-i command. So see how to use rand-i to generate the appropriate array. Okay, and now you need to sum across each roll. So the next step is to across sum across each roll of the dice to get the sum of the values obtained in each throw. Okay, so that is the variable you need to calculate the average dice. So average dice is simply the sum that you have calculated just above divided by the number of dice. So number of dice. Okay, and his dice is something that you have to sort of calculate in a running way. So one way to do it, and by no means is the only way, but one way to do it is to first initialize his dice to zeros, and then look at the sum of the values of the dice throws in each throw, and then just keep adding it to the appropriate entry. Okay, so look at each sum for look at the sum of values for each throw and tally it in the appropriate location in his dice. So it's a simple case of tallying, like how many times you obtain a 4, how many times you obtained a 5, how many times you obtained a 10, and so on and so forth. So it's a very sort of simple operation which you can do in many different ways, and I won't tell you this is the way you have to do it, but you can do it any other way you want. So again, you're asked to test your function with 5 different inputs, and you should see that as you increase the number of rolls, the distribution approaches the shape of the normal distribution. So again, not a very difficult problem. The last problem, ironically, is probably one of the easiest problems in this whole assignment in terms of the number of lines of code you have to write. So here let's look at what it's asking you to do. So you have to calculate the stats of some measurements, and the measurements are an n by p array of values. So each row consists of p measurements of a quantity, and the second input values is the x-axis. Okay, so values is the x-axis in the plot that is shown in the figure. Okay, in figure 3, and measurements is uh, p measurements at a given x value. Okay, so all you have to do is just calculate the mean value for each row of p measurements and the standard deviation for each row of measurements. So again, you can use the inbuilt MATLAB functions called mean and standard deviation. I think this standard deviation is double D. Let me confirm that. Or just STD actually. Yeah, standard STD. So you can use these MATLAB functions to compute the mean and standard deviations. Now, two things to remember in this one is that number one, you are computing, so compute the mean and standard deviation along each row. Okay, so you're computing the mean and standard deviation along each row. And secondly, it says you have to use the n-1 normalization for standard deviation. So n-1 normalization. So if you see the help of MATLAB, see help uh, std, you'll see that MATLAB computes two types of standard deviations, one with uh, a denominator of n and another with n-1. So you want to use the one with n-1, and you can specify that using a flag. So the details you can find out in the help of the standard deviation function. And once you get these two values, then you can go ahead and make this plot any which way you want. You've learned many different ways to create these kind of plots. So you can use something like error bar or something to get this plot. So that's it actually for this assignment. As I was saying, this is a very, very simple assignment. Not shouldn't